Many people will have probably been introduced to space exploration through the images of Apollo 11 and the first humans landing on the moon, including its commander, Neil Armstrong.
2, 1, 0, all engine running. Liftoff, we have a liftoff, 32 minutes past the hour. Liftoff on Apollo 11.
So we actually was sitting in the living room and watching the moon landing, and of course that was an amazing event, and I think it's been seen by several hundred million people was watching that landing, and so that of course something you never forget.
It's one small step for man, one giant leap for mankind. Hippity hoppity, hippity hoppity, hippity hopping over hill and dale.
Welcome, Pål Brekke, to the Shades of Life podcast, and thank you for joining me today.
You're welcome.
So Pål, you live in Norway, but you visited us in the UK recently, and you invited me to come to one of your presentations at the Imperial College in London. And the presentation was both mesmerizing and extremely original all at once, because you connected your presentation about space to music, as many rock stars have been inspired by space over the decades. So I wanted to ask you, how did you come with this idea in the first place? And are you a music fan in addition to being a specialist of space?
That's a good question, actually. But yes, I'm always been very fascinated by music, and I love to go to concerts and listen to lots of music when I was the whole my whole life, and I also play a little bit myself with keyboard and guitar. So, but this project started actually quite many years ago when I was invited to schools to give lectures, replacement for a teacher, and in particular when young people are in the 15, 16, 17 years old, when you get an external teacher, it's very easy to just close your eyes and kind of sleep through the hour.
Yeah.
And I noticed that every time I had a video with some sound, they kind of opened their eyes again and they looked and followed the attention. So, and then again, my interest for music and the idea that when you listen to lots of these old, at least particularly older records, very many of them has been inspired by space. That's why I put this together, and it's been expanding and improving over the years. But so the background came from keeping students awake for 1 hour, but now it's been much more focusing on the nice story and connection between the music history and also space. So that's the start of the whole thing.
Yes, so that was a strategy for your students' attention then. And that works. I mean, when I was in the room in the theater at the Imperial College, I looked around and it was a mix, of ages, students and people like me who came, and everyone was like mesmerized by your presentation. So it definitely works. You actually used a lot of music soundtracks during the presentation. Space has definitely inspired a lot of musicians. So I wanted to ask you, do you have a personal favorite soundtrack about space?
I think one of the bands I used was an American band called 3 Doors Down.
Okay.
And of course, since I'm a solo physicist in the beginning, so they have a picture of the sun on their debut album, and they also have a song called Away from the Sun. And I kind of like that because they singing about moving away from the sun, just like the solar wind moving away from the sun, how solar storm escaping the sun, and what actually creates the northern lights. We have this sun-earth connection kind of embedded in that song. So that's kind of my favorite. And also since they when I worked at NASA, they came to me and asked if they could use our pictures. Actually, asked for permission, and not everybody did that. So yeah, that song have a special meaning for me.
Oh, that's fantastic. I will definitely check it again. You used it in your presentation, I guess?
Yes.
Okay. There were so many, like, they were all fabulous. So, Paul, you are a solar physicist, an expert on the Northern Lights, and an internationally recognized lecturer. I wanted to ask you to start with what inspired you to become a space scientist? Was it a vocation from an early age?
Kind of, if you go all the way back when I was very young, my dad actually worked at the Solar Observatory north of Oslo when he was young.
Oh.
But he jumped off science and ended up being a high school teacher. But I remember the first time we saw the Northern Light in South Norway, and he took me out at the night, and explained what the Northern Light was. So that kind of inspired me a lot. But then when I started at the university, I wasn't really planning to do space physics. I was trying to do physics.
Okay.
But then, for just a coincidence, there was a part-time job announced at the Institute of Theoretical Astrophysics. So I applied to one of those part-time jobs, and I got the job. And the job there was to actually take picture or spectra from space, from rockets and from the space shuttle, to digitize them, get them into the computer, because they were taken by black and white film. So that connected me into real science. So then I decided actually to follow that path, and go into solar physics. So that's a little bit coincidence, but yeah, it was a lucky choice at that time.
Yeah, that got you started. That's fabulous. Um, so I enjoyed your presentation so much. I was wondering, where do I want to start this conversation with you? Because you shared so many, things and events that happened with space or in space. But many people will have probably been introduced to space exploration through the images of Apollo 11 and the first humans landing on the moon, including its commander, Neil Armstrong. And it probably remains one of the biggest wonder moments in human history, and Wonder Men or Superman at the time. Is it an event that captivated you? And I don't know if you were born when it happened in 1969. So can you tell us?
Yes, I was born in 1961, so I was 8 years old. And
Okay.
again, since my dad was more than average interested in space, and he had a TV at that time, so we actually was sitting in the living room and watching the moon landing. And of course, that was an amazing event. And I think it's been seen by several hundred million people was watching that landing. And so that, of course, something you never forget, even if I'm only 8 years old. But that, of course, inspired me a lot to be interested in space. Certainly.
Yeah. Oh, wow. Oh, I'm so glad that's like you are a living witness of it. That's amazing. I was born in the 70s, so I didn't see it, unfortunately. So one of my favorite images of space, and I can't remember if you shared it in your presentation, so let me know, but it's one of the most iconic images called Earthrise. And it is a photograph showing the Earth from space and part of the moon's surface, because it was taken by astronaut William Enders on Christmas Eve 1968. And it was during the Apollo 8 mission, which was the first crewed voyage to orbit the moon. So it happens before the moon landing, a year before or so. I also wanted to bring to your attention this particular picture because it has been used in recent times as an emblem in the logo of an important climate media platform called Earthrise Studio, which was founded by 3 young millennials during COVID, twins Jack and Finn Harris and Alice Eddy. And they are all 3 climate activists and environmentalists that are well known all over the world. And for me, it is great to see that a picture that was taken decades ago is still inspiring the younger generations today. So I wanted to ask you, why do you think this picture has lived for so long and has captured people's imagination so much? And second question, do you have yourself a favorite image from space?
Yes, of course, the blue planet coming up, racing over the horizon of the moon was just amazing. And I think you can see the planet is a small little sphere out in space. The blue dot with a very thin atmosphere. So it kind of also shows that the Earth is very fragile, and we need to take care of this planet. And when it comes to my own maybe favorite picture from space, it's a little bit similar, but there was this spacecraft that was been orbiting Saturn for many years called Cassini. And it's been exploring the ring systems and the planets, the moons around Jupiter. Saturn. And then one time when it was on the far side of Saturn, it took a picture where you can see part of the ring system, but between the rings, you can see a small little blue dot. Okay. And that was the Earth, seen from Saturn. So that picture is really a famous one too, that we live on a small little dot if we're moving away from the Earth, like on a distance from Saturn. So that, I think that's one of my favorite pictures. I think I also used that in my show before we were playing some Vangelis and talked about Cassini spacecraft.
Yeah, I think I remember it, and yeah, that's an amazing one as well. I think for Earthrise, if I remember well, I think I will have to double check that. But I think because it was at the time a picture taken on film, I think it was one of the first pictures where we could actually see the Earth in color as well. Mm. So that also probably participated to capturing people's imagination, which was amazing to see the Earth in color for the first time, like a blue planet, basically.
I can maybe add a little thing here, because it's there's been some orbiters around the moon, both Japanese and others, and they have taken similar picture of the Earth coming up over the horizon now. And as you also know, the Artemis program, they're going to launch 2 or 3 people that are going to go in orbit around the moon, just like Apollo 8. Before they're actually going to land on the moon later, but in 2025 they will kind of repeat the Apollo 8 mission and probably see exactly the same Earthrise again. So that's interesting.
Wow, amazing. Yeah, decades later, yeah, replicate the same picture. I will definitely look out for that one. So at the time of the first moon landing in the 60s, I think we've all learned that at school during our history classes, there was a space race between the USA and Russia in the context of the Cold War at the time. Would you say that there is still a space race taking place today? And who are the main actors of space exploration nowadays? Because I know you probably know this very well, having worked at the NASA and etc.
Yeah, no, I would probably say both yes and no, because it's a little bit different. After the Cold War and the space race at that time, all the countries starting to collaborate much more, because first of all, it's very expensive to send things out in space, and in particular when you're building like the space station, that was a collaboration between Russia and US and Canada and now also European Space Agency. And after the tragic war in Ukraine, we don't collaborate with Russia anymore on most space activities except one, and that's this International Space Station. And the reason that we're still collaborating there is that we are depending on the Russian spacecraft to lift up the space station a few times every month, because it's losing altitude all the time. But we also have kind of a race to get to Mars. The ESA, NASA, and others trying to get there. SpaceX go there. China will probably also try to go there. So in many ways, it's a little bit a small race going back there too. But we still have to acknowledge that the commercial space business has been increasing a lot, and also have been important in exploring space and using space.
Yeah, that's really interesting what you said about Russia. I actually didn't know about this collaboration still existing. So that's really interesting to know. And I'm glad you bring up the commercial space. We are going to talk about it again later in the conversation. But I was reading an article recently, and I had not forcefully followed all the news around that. But we know there is a war between Ukraine and Russia at the moment, obviously. And Ukraine has lost all their internet connection on the ground. So they had to use SpaceX from Elon Musk to actually connect to the internet via their satellites. And it's a private company. And it just shows that a private actor can actually have an active role. And what I didn't know is that I think it was at the end of 2023, there was a military action that Ukraine was planning on Russia. And at that time, Elon Musk said, well, I'm just going to cut the internet because I don't want to be part of a military action. And it was like this crossover between, a basic need or something that could be seen as a basic need today with internet. But then it's contributing to a military action. That's just so interesting because there are different actors at play now in that space.
Yes, that's right. And it's also the same with the GPS system, the American, it's kind of military system that we all using in our cell phone today to get the position and get the timestamp and so on. But US can also turn off GPS over certain regions. If there's a war and a conflict someplace, they can actually control who is accessing the navigation system, just like Elon Musk can do with his Starlink.
Yeah, that's really interesting, amazing. So you mentioned the missions to Mars. It seems like almost the next big thing happening that is the closest to us almost. So the first crewed Mars mission from my research, which would include sending astronauts to Mars, orbiting Mars, and then a return to Earth, is proposed for the 2030s or the end of the 2030s. You will tell me if it's wrong or not. How realistic do you think is that? And also I wanted to ask you, because you are a scientist, how significant is it for a scientist like you, with your background, for us today or in 10 years or 15 years time, to be able to accomplish such a mission? Because, for people like me who are not scientists, should we look at it as a scientific breakthrough? Should we look at it as a moment of wonder, like it was at the time when the first men walked on the moon? And also one question I wanted to ask you, it's a lot of questions, but one question I keep asking me about the mission to Mars is, does it have benefits for us as well?
Yeah, that was many questions. And first of all, I think it's a big challenge to go to Mars. So I will say it will closer to 2040 before we get there, maybe, because there's still some challenges that we haven't really solved. And first of all, if you go to Mars, it takes about 6 months to travel to Mars, and then you have to stay at Mars for 1.5 years before you can get back, because you have to wait until Mars and the Earth is close together again. But at some point, they are on the opposite side of the sun. So you're talking about 3 years outside the Earth's protective magnetic field. So radiation is one of the biggest challenges, I think, when you both travel there, even in the spacecraft. These cosmic rays and particles from the sun can penetrate the spacecraft and give you radiation sickness and so on, and actually a lethal dose if you're really unluckily lit by a very strong solar storm. So we need to find ways to protect the astronaut maybe better on the way to Mars. Yeah. And also, if you manage to go to Mars, you cannot just walk around and live in the space capsule. You probably have to dig yourself down in the bunker or something, living underground, because of the Mars doesn't have a protective magnetic field like the Earth has. So it's much more radiation at Mars. And then, of course, you also talk about all the stuff you need to bring. You have to probably grow food. Water, there's no water on Mars except maybe the poles. So there's all these things that makes it really hard to think that we should go there other than maybe stay there for that 1 year and go try to get the people back again.
Yeah.
And if we manage to do that, of course, will be a major breakthrough to do that, because we have only been to the moon a few times, and then we only were there for maybe a few days. It took 7-10 days to go back and forth to the moon. So we don't have really a long experience or good experience being outside the protective magnetic field we have around the Earth. So how will a human react to that radiation over long term? And also, of course, the weightlessness for many years is also something that the body might not like to do. You're losing bone mass, and yeah, there's many things that makes this really hard, I think. And we only have we landed on the moon. We only have done that, or we only landed on another celestial body once for the first time. So
Yeah.
even if we go to Mars now, we have been to the moon. So this will not be maybe as big as the moon landing in many ways, even if it's bigger, much bigger challenge to go to Mars.
Yeah. And so what would you say are the benefits for us? Are there any benefits?
I think we can explore Mars in a more hands-on way than we can do with the rovers that are moving around here, analyzing something that is drilling a little bit and analyzing some substance. But to be there and to maybe dig down and feel and do some more research on what's under the surface. If there is any ice or water we can use, or material we can use for building bunkers and so on, you can maybe think you can use some of the dust and so on to compress and using 3D printers basically to make bricks and other things you need up there. So I think it will be useful for us to get that experience for long space flights, because at some point we might want to go either further out in a solar system or something. So that experience will be very valuable, I think, for humanity.
Yeah.
And very often, sometimes we can develop something to do something new that we've never done before. Very often you can use that knowledge to improve other things here back at Earth.
Yeah, that's amazing to hear you talk about it. It's I think it helps us crystallize it in the reality when you talk about it. That's amazing. So people don't forcefully need, though, to travel to space to enjoy some major space events. And just this year, the USA in particular, we are lucky to have a total solar eclipse on April 8th. And I think you said the best places where to see it were from Texas and Mexico. Is that correct?
That's right. That's when we had typically the best weather forecast. There's much less clouds on average in Mexico and Texas compared to the state that was further north along the path of the totality this time. So, but it was a kind of scary days, and because there was forecasted really bad weather also over Texas and Mexico.
Oh, yeah.
So we were very lucky to actually see the eclipse because it cleared up just a few hours before the eclipse. It was raining that morning, and we some people want to drive a long way to try to find some better
I
weather.
went to Texas in March, actually, and from London to Austin, it took me 26 hours to get there because of bad weather when I arrived, and we couldn't land, which is quite unusual for this location. So for people, did you go there, actually? I forgot to ask you this.
Yes, I went there with a group of 35 of the Norwegian enthusiasts. So I was kind of a guide for them. And we also have a Norwegian TV weather lady with us that also provided the best weather forecast all the time. So it was an amazing trip for these people.
Yeah. Very good. So for people who, like me, couldn't go there and would want to experience the wonders of the universe more closely to home, when is the next solar eclipse and where do people need to travel to see it in its totality?
Yeah, there's almost one eclipse every year, or every 1.5 years, someplace on the Earth. But very often it's in the Antarctic, and it's close to the North Pole or out in the ocean. So sometimes they're really hard to get to. But in 2 years' time, it will be one that very easy accessible. It will come in 2026, 12th of August, it will come over parts of Iceland, and then it goes over North Spain and out in over Mallorca, an island close to Spain. So that's an easy access for most people in Europe to just travel to Spain, for instance. And in UK, it will be only partial, maybe 85-90% totality. But you need a totality to
good.
get the
Yeah.
part of it, and that's what you need to do.
Yeah, still good. I will remember it because the 12th of August is my dad's birthday. So in 2 years, I will definitely remember that one. So I wanted to ask you, what about the UK where I live? When is the next total eclipse? So the next one is not too bad if it's, that percentage. But I remember that you said we will probably not be alive to see it. So when is it?
It's in 2090. So yeah, we will not live at that point, I think. So, but for those who are very young now, they will be able to maybe see it. So no, so you should try to travel to some of the other places, and there will be also some other eclipses that might be easy accessible the next 10 years or something. So, but 2026 will be a good option for those who want to experience one of the nature's wonders that everybody should see once in a lifetime.
Yeah, definitely. So we have enjoyed a lot of recent events connected to space, and especially a series of powerful solar storms with intense to extreme solar flare and geomagnetic storm components have been ongoing in recent weeks. And there has been several since, I think, the 10th of May this year, which was very recent. So I wanted to ask you, because it has had a lot of after effects. Can you explain what these solar storms are and why are they happening?
Yeah. Some of you have probably seen some dark features on the sun sometimes. They're called sunspots, and they were discovered by Galileo for the first time more than 400 years ago. And these dark spots are basically places where there's very strong magnetic field coming out of the sun. And sometimes these magnetic field lines will connect together and cause a very strong explosion that sends out a lot of X-ray and UV radiation that will be absorbed in the Earth's atmosphere, and that can interfere with some of the radio communication on Earth and so on. But sometimes also lots of gas and magnetic field are hurled out in space with large velocities. And when these clouds of gas reach Earth and connect with the Earth's magnetic field, you get a very strong, what they call a geomagnetic storm. The Earth's magnetic field is shaking a lot. And that's when you also get very, very strong northern lights. And the stronger geomagnetic storm, the further south the aurora will move down. So in this case, it was one of the strongest geomagnetic storms we have seen, at least in 20 years. But some people argue that it might be we've never seen northern lights that far south in several hundred years, probably, because they could see the northern lights in Italy, in Canary Island, Key West, and even Caribbean. And we haven't seen that at least since 1959. So this is a very special and very strong geomagnetic storm. And we think that more than a few hundred people saw the northern lights for the first time in their lifetime, because they're living places where there have never been northern lights in a few hundred years.
Wow, that's absolutely amazing. Yeah, it's been in the news like so much, and people are so excited about it. So as you said, as a result of these solar storms, we have seen northern lights at far lower latitude than what it is usually, and in both the northern and southern hemispheres. And I think there is like, if you have a northern light in the North Pole, you have one in the South Pole, because there is a symmetry. Perhaps you will explain better what it is to us. But yes, we've seen them everywhere. We've certainly seen them in the UK, and we have seen them in France. And you were mentioning much lower latitudes, which is amazing, because usually you see them more in higher latitudes, like Scandinavia, where you live, Canada, Siberia, perhaps Greenland, for sure. And it is a phenomenon. People love the Northern Lights, and for good reason, because it is such a magical spectacle. But as it happened, I did a trip to Norway about a year and a half ago, and I went all the way very north to Norway to a place called Tromsø. And then I used like an old French meteorological ship to go through the fjords in this region. And we had a brilliant ecologist with us he was doing lectures every evening to us. And one evening he did one about the Northern Lights. And I thought I knew what Northern Lights were, but after his lecture, I realized I didn't know much about it. And after seeing people, going out, enjoying the Northern Lights, etc., I think it can be useful to tell a little bit more about the Northern Lights to people, because it's all about radiations. And if I remember well my lecture from a year and a half ago, there are also the colors that you see indicate a different level of radiation. Am I correct? Am I still remembering it well?
Yeah. The Northern Lights starts at the sun. Like I said, the sun is sending out particles, protons and electrons, that charged particle that move through space, and when they arrive at the Earth's magnetic field, they will then be captured somehow by the Earth's magnetic field.
Yeah.
And since the Earth has a bar magnet in the center, the magnetic field lines comes out of the polar regions and go around the Earth and enters back into the southern hemisphere's polar region. And since these are charged particles, they cannot really penetrate perpendicular to these magnetic field lines. That's why they don't penetrate along the equator and go down to ground there. They have to enter in the polar region, you may say.
Yeah.
And when they enter inside this Earth's magnetic field, what we call the magnetosphere, they will then spiral along the magnetic field lines down in the polar regions. And so they're ending up typically between Norway and Svalbard every day. There you will see the Northern Light every single day, as long as it's clear weather. And the stronger geomagnetic storm, this aurora band will then expand and move southward. But what really makes the atmosphere to glow is these particles when they're coming down in with large speeds, and then the densities start increasing when they get lower and lower down in the atmosphere. And from about a few hundred kilometers up down to 80 kilometers, that's where they collide with atoms and molecules in the Earth. And when it collides with an atom, you will transfer some energy into this atom. And if you know how an atom works, it has a core with protons, and then you have electrons flying around, just like planets flying around the Earth. And when you add this energy from this particle, when they collide, just like you're playing pool, one ball hits the other one and transfer energy to that ball. But instead of this atom moving around, it sucks up this energy, and the outermost electron, which goes in a certain orbit, jumps out to a higher orbit because it had excess energy suddenly. And that electron doesn't like to have that extra energy. It wants to try to get back to the orbit it belongs. So just a few milliseconds, it will jump down again to where it belongs. But to do that, you have to release energy. And you do that by sending out a light photon, a small little blink of light, which you call a photon. So every time you have a collision, an electron jumps up and jumps back again and releasing that energy it received as light. And depending on what atoms and molecules that are affected by this particle, you will get different colors. So typically, the green color is the one most people have seen. Yeah. This is the oxygen that's making the green light. And then you have also oxygen making some red northern lights on the top, higher up in the atmosphere. And when it's really intense northern light, you also get very purple, pinkish down on the bottom, which is nitrogen. But these are the three elements that basically creating
it's
this.
It's more the heights, right?
Yes, the height that is depending on the color. And most people have seen fluorescent light in the ceiling. There's light tubes you have in the ceiling to give you light in the room. Exactly the same thing happens inside this tube. there's already gas inside this tube, and then you turn on the power, and then electron flies to the electricity cord up to the lamp, and the electrons flies to that gas and colliding with the gas molecules or gas atoms, and then they will then get this gas to get excited, so all the electrons jumps up and jumps down again many times, and creating light as long as the electrons flying pass.
Oh,
So in many
wow.
ways, the Northern Light is a super big commercial science, because the same effect you have in the commercial science, and also the old-fashioned TV tubes, the big bulky TV you had before.
Yeah.
That was exactly the same mechanism
Oh,
making
okay.
this thing. Yeah.
Oh, so taking inspiration from space then. Wow, okay, I didn't know that. So I did want to ask you though, is there any health risk for people related to the Northern Lights? Because I remember our guide ecologists saying, especially with people who have a problem with their heart and the machine, I can't remember the name, some people need to be careful.
Yeah, in principle, the Northern Light itself is not dangerous, but it's the same effect that making the Northern Lights. The radiation from space and so on can be harmful, but that's only typically if you are in space or outside the magnetosphere.
Okay.
So the Apollo astronaut was just lucky to not be hit by one of those big solar storms at that time. But we on ground are not really any risk. It's only our technology-based society that can be affected. So your GPS might be uncertain, so you don't find your way for some hour or something. Radio communication can be difficult, which is crucial if you have a rescue operation. Drilling for oil and gas can be difficult because they're using the Earth's magnetic field to maneuver. So many of these things that can be affected. So you will feel the effect more like things that you normally are used to have to work. It will not work anymore. There are some studies that have looked at if there's an increased risk of cardiac arrest during geomagnetic storms. I don't think it's very conclusive yet, but there's some studies that have looked at an increased number of people getting heart attack or something like that when there's very strong geomagnetic storms and so on. But we know that some animals are affected, like pigeons and migrating animals, because they're using the Earth's magnetic field to navigate. They have like a compass, small little eye filing or something in their brain that can detect variations in the Earth's magnetic field. So they're using that like a compass, and then you get confused when there's geomagnetic storm. So this is a very well-known phenomenon for people when they're having pigeon races and so on.
Yeah, amazing. I mean, I suppose also people in your countries, in the northern countries, you must be so used to the northern lights. It's like when I did this trip to Norway, it was in December and it was a polar night. And this is when I understood from local people how important the sun is for them. So it almost makes you look at the northern lights under a different light, because the importance of the sun is so big. When I went there were days you couldn't even see it, or you would see it for 1 minute on the line of your horizon, and then it would disappear. I don't know, it gives a different dimension to the northern lights for this region, because it's just so important.
I think the Northern Lights has been embedded in history and myths all the time. Before they didn't know what it was even, so they was always connected it to bad gonna happen, or dead spirit talking to you, or something like this. But the Northern Light is very dynamic too, because it's you have to always be very patient, because the Northern Light, even if it's forecasted a lot of Northern Lights, it typically not Northern Light the whole night. It comes in bursts, and maybe only 1 or 2 times at night. So sometimes it will come at 10 o'clock or 11, or sometimes 12, sometimes 2 o'clock at night. So if you go to bed at 12 and haven't seen the Northern Light, you can bet it will probably show up at 1 o'clock or 2 o'clock. So you have to be patient and not go inside before the night is over. That's my advice to people.
Yeah, actually, I mean, the one time when I saw the Northern Lights and it was incredibly beautiful, I was on a trip in Greenland above the polar circle. I was doing a crazy cross-country skiing trip there. And it's only after, I don't know, perhaps 6 days within the trip, but because the conditions, and I did this trip in March, so it was very cold, the conditions were very tough. And 6 or 7 days within the trip, you know, when you start the trip, you think about the northern lights, that you're probably going to see them, and you hope to see them, obviously, but then, you know, there is never any guarantee. But 6 days, 7 days into the trip, we totally forgot about it because the trip was so hard physically. And I remember we were all having dinner in a communal tent. And at the end of it, it was dark and we all went to our individual tents for the night. And this is when we came out, and it was a giant green spectacle in the sky, and it was so beautiful. And perhaps even more because it was unexpected. We had forgotten about it.
So nice.
Yeah. What was your perhaps best memory of Northern Lights yourself?
I think I've seen Northern Lights so many times, and of course at Svalbard it's very amazing because you can also see the Northern Lights in the middle of the day there in the dark time. But it's a very special place to see the Northern Lights because you can also see Northern Lights in the daytime when parties come straight in the polar night into the what you call a cusp regions, like an opening in the Earth magnetic field. So in the middle of the day you can see some Northern Light which is much more reddish than you can see otherwise. So that's been very fascinating to be able to see that one. But I must also say that the Northern Light we saw now this year, 10th of May, amazed even me because I was in the far south of Norway and suddenly there was so much color in the sky. And I've never seen so many colors and so strong Northern Lights so far south myself even. So that was probably an extremely good memory.
Yeah. 2024 is a good year for Northern Lights. So Pål, in your presentation at the Imperial College, you shared an image or a video, I can't remember, I think it was moving a little bit, but it was showing the staggering number of satellites in orbit around the Earth, and that's not something we forcefully think about because we can't really see them from where we are. But to me, when I saw the image, I was like, wow, it looked like a massive spatial traffic jam at peak hour, like we know with cars here on the motorway. So do you know how many satellites are up there in total today? Are we being watched? What is their purpose?
Yeah, today we have about 15,000 satellites orbiting the Earth. And a few thousand has been launched just the last year because particularly SpaceX is launching the Starlink system, which is consisting of many satellites. But it's starting getting crowded there. So, but be also very useful because we're using satellite to almost everything in a daily life now. And we're using it for giving good weather forecasting. We're using it for communication, navigation like GPS. That's why you're finding a way with your cell phone. We observing the Earth, we observing climate, and of course we also do science to look at the sun or the galaxy. So the satellites are very important for our society today.
Yeah, I think when I researched SpaceX and what Elon Musk is doing, because he's very active in that space, I think he has an objective of launching 42,000 satellites. So if there are 15,000 today, that gives an idea to people of what we are aiming for in, not so long from now. One question I wanted to ask you as well, because, everybody doesn't work with space like you do. And so sometimes it can be a distant universe in itself. And especially for people who work in the climate sphere, around climate change, there has been a lot of criticism in the recent years due to the development of commercial space activities, billionaires traveling to space. And of course, it makes the headlines in the newspapers. And even in the UK, Prince William, who is usually very reserved, but he voiced his concerns publicly and encouraged the billionaires and what he calls the great minds to focus on trying to repair the planet rather than finding the next place to go and live. So I wanted to ask you, as a space specialist, and you've worked most of your life in that space, what is your own opinion about these developments, the commercial space? And is there any benefit to it from your perspective?
I think it's a lot of benefits to space in general, but also the commercial space program. And SpaceX got money for NASA to develop these rockets and make things cheaper. So NASA's been helping Elon Musk in many ways to do this. And the goal for NASA was that instead of them using resources and money to launch things into the space station and food, water, equipment, and people, and in particular after the space shuttle the program was stopped, the only one that could launch people in space was Russia, and we were very depending on the Russian launchers. And of course, now after the war, that was a very good choice to do that. And so SpaceX got the contract for NASA to build a system that could bring things up to the space station and bring people up and down from the space station too. And we do the same thing home, you and me too. If you want to send something to a friend or something, you're using the post office or using FedEx or DHL, to transport something. You don't do it yourself anymore. You outsourcing it, and that's what we kind of do today. We're renting SpaceX to do what we want to do to bring up in space. The other side is, of course, the tourism part of it. This is what Branson and Bezos and the other people doing to try to let people go up in space and float around a little bit and go down again. That's a little bit different from what SpaceX is doing right now, because they're doing a service for NASA or ESA and other space agencies. And what also happened is that SpaceX had managed to get the price down from maybe $100,000 per kilo down to maybe $25,000 per kilo to lift something in space. So it's been a big improvement in the cost of launching something in space too.
Yeah, that's amazing. Yeah.
And then that also means that other countries and poorer countries can afford to launch national satellites, for instance.
Yeah, that's a really good point. And that's important for the developments of all types of countries. Yeah, definitely. So just to dive a little bit deeper in this question, because I know, a lot of people who are active in the climate space will probably look at this conversation, but looking at the other side of the coin, because there is never only one side. The fact is that space developments in the last 2 decades have greatly contributed to our understanding of our planet's climate. And I wanted to ask you, can you perhaps highlight some of the benefits of going into space and how space innovation, when it comes to helping us address climate change in particular, what has been their role?
Yeah, today, the knowledge about climate change, most of that come from satellite observations. We have what we call Earth observing satellites that are looking down, and they're looking at the atmosphere, aerosols, looking at ice, algae, and forest, and so on. So you can then monitor forestation, deforestation, and so on. So satellites has played a major role to tackle the understanding of climate change. And so they are very useful for that one. And Norway is supporting lots of these programs through the European Copernicus program, which is an Earth observing program that many countries subscribes to. And Norway is also one of the biggest users of satellite data. And in addition, we have the world's biggest satellite station is at Svalbard in North Norway. So this has been very useful and given us lots of knowledge. And the other thing is that when we're building something for space, a small new sensor or an instrument or something like this, it has to be much better than anything we've built before. It has to be very robust and tackle being in space. So when a company develops something and deliver it to ESA or NASA or something, they can then take the same product and sell it to the medical industry or some other people. Yeah. That makes our life and the medical system or other things much better. So there's lots of benefits here on the ground too from the development of all this technology we do for space.
Yeah, no, that's amazing. Thank you for bringing that up. That's not something I would have thought about. And I can only encourage people, to do some more research, go beyond, the media headlines, because it's very easy, to direct people in one direction and say, oh, commercial space is bad and we need to focus on climate change, which is true, by the way. But there are a lot of benefits from using the space. It's a space in itself, obviously. And there are things that we can only do from space, and it can also lead, as you're saying, to innovations that can actually also be useful for us back to Earth. So
I should mention that actually on the space station, there's lots of research on medicine too, to making cleaner medicine, and medicine that may be hard to make at ground. So there's lots of stuff going directly into medical research on the space station too.
yeah, amazing. So moving on a little bit, because there were so many things that were interesting in your presentation at the Imperial College in London. I can't mention all of them, but one I wanted to ask you. We obviously live on an incredible planet, the only one we know so far where there is life. Is that true? Can you give us an idea of how many planets have been discovered so far? Because I didn't know we had discovered so many. And do you have any favorites yourself?
We have discovered about 5,000 planets, and that's only because we have looking fairly close to where we live ourselves. These exoplanets are very difficult to detect because they don't send out light themselves. They are only reflecting some light from the star they're close to. And since the planets are very small compared to the star, it's really hard to see them. So there's some few techniques they're using to find those planets. And one is when the planet moves in front of the star, the light from the star will then be reduced a little bit. And that's one way of detecting these. But then you can only detect planets that are, we see the stars where the planets go in front of the star. But if you see the star from the top, for instance, you will never see a planet passing in front of it. So we think now from all the planets we found so far is that almost all the stars we see in our galaxy has one or more planets. And that, of course, increasing the chance of being some sort of life forms or something around some of those planets. And that's what we're trying to look for. So when we have confirmed the planet from one of those techniques, then we're using the Hubble Space Telescope or now James Webb Telescope to try to analyzing what kind of gases are existing in the atmosphere of this planet. Because maybe you could see some traces of there being some sort of life on that planet. It could be plants or something else that releasing CO2 or whatever. That's enough for seeing maybe signatures for possible life on these planets. But so far we haven't found anything of that yet. But the hunt is still on.
It could be possible. Okay, no, that's amazing. I mean, I would encourage people to look out. If you bring your presentation to another place like you did in London, I would encourage them to go because I discovered so much in it, even the size of the planets. There are massive red stars, I think you called. Visually, it was stunning, and you really need to see it. It was absolutely mesmerizing, and I learned so much. So talking about other life in the universe, and if we're talking about space, I cannot not ask you the question. And I remember you've shown a map on Earth, so I'll let you talk about it. But what about aliens and alien theories? Do you believe that there is life somewhere else than on Earth? I think we just answered to this. But some people are also convinced that there are forms of alien life on Earth already. So what's your view on this?
Certainly with all the stars in the galaxy, we have 200 billion stars in our galaxy. And if most of them have stars in the planets, and then you have all the other galaxies, billions of the galaxies that have many billions stars. So of course there will be the chance that some sort of life someplace out there is quite big, I think, and the question if it's a life is existing today, or it has been existing before, or will be in the future. Because when you come to distance again, it's really hard to think we can communicate. And the distance are maybe the biggest challenge, I think, and that's why I'm very skeptical to think that there's been some aliens visiting the Earth for many reasons. But the one is that they have never really made themselves clear. There's nobody that has a tentacle of an alien or a bolt from a spacecraft or something like this. And then, like you mentioned that map, there's a map online on YouTube that shows where all the UFO sightings have been the last 50 years, something, and 95% has been landing in the United States, and that's kind of, or UK. So I usually say that maybe they only can speak English. That's why they have to go to these countries that have an English language.
Yeah.
And also the other interesting thing is that all the pictures of UFOs are very old, black and white picture from the 60s, 70s. And today, when everybody has a cell phone with a super camera, nobody takes pictures of UFOs anymore. So I find it hard to believe that there's been anybody here since we don't have any evidence so far. So, but both NASA now and other agencies in the United States is taking this a little bit more serious now to try to understand some of the observations better, because we need better observation, better data from what people are seeing, and maybe trying to connect it to UFOs and stuff. And the UFO is basically just an unidentified object. It doesn't mean that there's some aliens inside it if you see something you can't explain.
Yeah, absolutely. Well, for now, it will remain a mystery and watch this space, I guess. So coming back down to Earth and closer to home, I wanted to ask you this because you are a member of the exclusive Explorers Club in New York. And I love everything exploration. So I wanted to ask you, how important is it for you to be a member and connect with fellow explorers, and how much are you enjoying this community?
No, first of all, it was an honor to be nominated to be a member. There's so many famous people and some great, not only explorers, but there's film producers there's musicians and people have been doing many things to promote science and exploration and so on. And you get to meet film producers, you get to meet astronauts and so on. And of course, that's really amazing to sit and talk with somebody that walked on the moon. And there's a saying, at the club that there's a club bar in the clubhouse there, and so if you sit and a guy comes up next to you and he say he walked on the moon, he probably have walked on the moon. It's kind of amazing. So yeah, so
Love the alcohol.
yeah, exactly. No, so it's been really amazing, I think, and we have an annual meeting in New York every year with a big gala dinner and so on, and also raising some funding for different projects and so on. So it's been learning to learn or meet a lot of new people and outside your own field, and that's very nice when you can talk to people that are doing different things what you do yourself.
That's amazing. I will actually have another podcast recording this week with someone who is also part of the club, a woman who has done a lot exploring the oceans. So this week I'm going to space and I'm going down deep into the ocean as well. So that will be interesting. I wanted to ask you, have you ever been to space yourself? And if you haven't, would you like to?
I've never been to space myself, and I actually applied to be an astronaut 25 years ago, but didn't reach through the loophole. There was a Swede that beat also the Norwegians, so we still haven't had a full Norwegian astronaut in space yet. But if I get an offer, I will certainly try to be part of it, go to the space station or go with SpaceX. Will be extremely fun, of course. But you can buy a seat on SpaceX, or Axiom Space is a commercial company that's renting space on SpaceX, and but I think you have to dig up about some 150 million English pound or something to get the seat.
It is still expensive. Perhaps in the next few
Yeah.
years it will become better. Okay. Then, because you've spent so much of your life, with space, working with space, I wanted to ask you, how do you look at space? Do you look at it as an escape, as a dream? What is your definition of it if you had to qualify space and what it represents to you?
I think that space looks very calm and very peaceful place, and it's a good place to do science from, both looking at galaxies and like James Webb. So I think it's probably more the scientific usefulness of space when I'm thinking of space, and not so much for floating around in space myself to dream and so on. But that will also be a very nice thing to do. I think to be in zero gravity, actually float. I've been scuba diving a lot when I was younger, and that's the closest you can get to being weightless is, of course, when you scuba dive, because then you're neutral in the water and floating, similar to what they do in space. And that's also why they using water tanks to train before they go to the space station, because it's very similar.
Oh,
But
yeah, of
I
course.
think I'm thinking most of the usefulness of space, how we can utilize space for the benefits of the humanity. That's most important, I think.
Yeah, that's a great answer. I mean, I look at it from a very different perspective, and I have a very weird dream that I've always had of flying into space. I don't know why. So that joins a little bit what you were saying, but it's also something that makes people dream. So that's great. And then I wanted to ask you this question because obviously, space planets play a role in astrology. So I wanted to ask you, are you interested in astrology, perhaps the science of astrology?
I'm not interested other than that it's interesting to read and see what they're trying to argue, but I don't believe in astrology. And the main reason is as a physicist, you know that if you believe that the planet's position compared to when you were born, how they were positioned, that the gravity from these planets will have any impact on you. It's actually the gravitational forces. You can calculate this, and the gravitational force from the midwife and her weight will be bigger than the effect from any planets far away, actually. And it's also even the gravity from on your body when you get born is also determined by what the floor in the hospital you were born. So there's so many other effects that will be much bigger than the planet's position, I think. So that's why I'm very skeptical to.
That's a very scientific answer. I like it.
I know.
It's
I
okay.
also think that if you're reading a horoscope, and if you put a little bit on edge here, if the horoscope say that you will fall down the stair next day, you were probably thinking so much about that stair and then falling that you're actually falling down that stair. So it's
I thought you were going to say it never happens anyway, but because it's a lot of things never happen. Okay, well, I like the answer. So, Paul, I like to finish this podcast with the same last question for each guest. If you were a color, what would it be and why? And I want to ask people the question because I find it interesting. I've actually worked with color all my life, so I'm very keen on color. But also, we are all very different, and I wonder what a color can tell us about each guest. And I wonder if you're going to use something from space or not, but please let us know.
I have a blue shirt on, I have blue eyes, so blue is my color. But the reason why I think blue is a nice color is, again, going back to the picture of the blue dot or blue sphere that comes up when the Apollo 8 astronaut went around the moon, and they saw this blue planet. The ocean is blue, and ocean and water is what's needed to bring life. So without the water, it wouldn't be any life there. So that's why I think blue is a very nice color, and also when it comes to the Earth and space in general.
Very nice. Yeah, I wasn't expecting this, but as it happens, I have 3 podcasts I'm doing this week. There's you and space, but the 2 others are ocean related. So I might have a lot of blue colors this week. It's possible, but I like that. So, Paul, thank you so much for joining me on the podcast today and for all your insights about space. I really encourage, again, people to watch out for your next presentation around space, because not only, the images you shared of space were beautiful, mesmerizing, you didn't even need the music, to captivate the audience, but adding the element, with the music from the rock stars over the years, it really gave it an edge that definitely keeps your attention throughout. So well done for that.
Thank you so much. It was a pleasure to be on your podcast here. So it's I love to promote science. So this is very fun.
Yeah, perfect. Well, thank you very much. And thank you, everybody, for watching and listening. And I will be back for another podcast very soon. Thank you.